let's look at the steps of this ideal or ultimate mechanism. So first, what we expect the mobile unit to be able to identify the available serving networks at the Wi-Fi side and in the cellular side, authenticate, and register seamlessly through each radio access technology, whether it's Wi-Fi or cellular. Then, we expect the cellular network to know, based on information that it gets from the Wi-Fi access point, from the cellular base station, and from the user itself, the mobile unit itself, what is the expected quality of experience at each radio access technology, and what is the load at each radio access technology. And as a result, what may be the radio access technology that may serve best the mobile unit. And then we expect that the cellular network will be able to toggle dynamically between the Wi-Fi and the cellular and vice versa, based on the criteria that we mentioned earlier: the potential quality of experience, the load, the quality of service requirements, and of course availability of networks. Even more than that, in some cases, some mobile devices may serve simultaneously more than one IP flow. For example, the mobile device may be busy in surfing the web, and on the other hand, it may be busy in a voice over IP call simultaneously. So we expect in this kind of ultimate, ideal cellular Wi-Fi convergence that the core network will be able to distinguish between these two IP flows and divert them to the best serving network. It may decide, for example, to divert the IP flow which relates to the web browsing to the Wi-Fi network and maintain or divert the voice call through the cellular network while they are being served simultaneously. So we expect to have this kind of mechanism in the ideal or ultimate cellular Wi-Fi convergence. And last but not least, we expect that during the mobility between radio access technologies, IP address will be preserved, and traffic from both radio access technologies can be built or will be able to be built, and the content is known at the core network. In other words, we expect at least to give this tool to the carrier, it is decision whether to use it or not, to be able to monitor and bill actually the traffic that comes also from the Wi-Fi radio access technology, and to be aware to the data that goes there, and this is mainly to comply with the requirements for lawful interception that is required in many countries. So let's have a look now at the various standards and standardization bodies that deal today with Wi-Fi cellular convergence. First is the 3GPP. The 3GPP actually generated several paragraphs and chapters which are dedicated to access to non-3GPP networks, where wireless LAN is definitely one of these technologies that these standards relate to. And the standard deal with network architecture, they deal with ANDSF. This is an entity that we'll discuss in the next session. It deals with IP address preservation, with authentication, and other mechanisms required in order to allow seamless roaming between Wi-Fi and cellular to Wi-Fi. So this is the 3GPP, and we have here a list of at least the main 3GPP standards that relate to Wi-Fi cellular convergence. The second important body is actually the Wi-Fi Alliance. The Wi-Fi Alliance started several years ago, an initiative based on 802.11u, and at that time it was called HotSpot 2.0, and then in the last half a year or so the name was changed to Passpoint. So actually Passpoint is a certification program that we will discuss soon in more details, and it makes use of the previous 802.11u standardization and in its extension, actually to deal with two main things. First is the identification of available Wi-Fi networks in a seamless way, in a fast way, and relates also to the authentication and security mechanisms that are required or actually mandated to allow this convergence. And there is the Next Generation Wireless Broadband Association. This is another body that deals with standardization related to Wi-Fi cellular convergence, and is mainly integrating the 3GPP and then the Wi-Fi Alliance standardization and add its recommendations. We'll remind him during our discussion. So let's discuss now one of the major pillars of the cellular Wi-Fi convergence mechanism initiated by the Wi-Fi Alliance, and this is the Passpoint. As mentioned earlier, the Passpoint is based on HotSpot 2.0 specification, which for itself is based on the IEEE 802.11u amendment. And as mentioned, it addresses the issue of seamlessly identify available Wi-Fi networks and the authentication methods and procedures towards these networks. So why do we need this Passpoint, or what was the situation? Actually, what is the situation now with the identifying and connecting to Wi-Fi networks that need to be improved by the Passpoint? So currently, before Passpoint is introduced, when a mobile device seeks a Wi-Fi network for internet access, it goes through the following stages. First, it uses the internally configured list of candidate networks identified by SSIDs like AT&T Wi-Fi. And if found, it tries to connect. If this does not provide any results, the user will have to go manually through every public SSID that it sees, and then see if he can connect to this SSID, if it is allowed, and try to connect to it to the internet. Sometimes you can connect to a certain network, but there is no connection to the internet, so it's a kind of frustrating. And during this process, the subscriber may be required by the network to identify himself and/or provide payment details, like credit card details. So it's a kind of tedious process to connect to unknown Wi-Fi networks. If you are lucky and your internet service provider operates a Wi-Fi network in your vicinity, and your your device is actually configured to recognize it, then it becomes easier. But if this is not the case, then you need to go through this manual process. So the Passpoint actually avoids this long and tedious process. It makes the whole process seamless, more user-friendly, and of course saves battery, because you don't need to operate for a long time both radios, and you don't need to go through this lengthy manual process. And by using Passpoint, actually you don't need a prior knowledge on the possible serving networks. You don't need it. Your device needs to be able to recognize the Wi-Fi networks that are advertised by the Passpoint protocol, but the Passpoint protocol have an information that assists your mobile device to do that. So let's have a look at the main elements of the Passpoint. The first one is network discovery and selection. Mobile devices discover and automatically choose network based on provisioned operator policy, user preference, and network availability. The other element is seamless network access. Manual intervention for selecting a Wi-Fi hotspot is not required anymore, since Passpoint performs automated association process. Devices can be automatically granted access to the network. The next element is multiple credential types. This relates to the authentication process. Passpoint supports first and most natural one, subscriber identity module-based authentication. It means that it can authenticate, or it allows to authenticate the mobile device based on the SIM credentials. Beside of that, it includes other mechanisms for authentication based on username password combination in the case that the mobile device does not have a SIM. The other element is the WAPA Enterprise Security. Actually, the WAPA or WPA2 Enterprise Security, this is a set of security procedures that were already standardized long ago by the 802.11i, but the Passpoint has adopted them and mandate a portion of them as a requirement for supporting Wi-Fi cellular convergence. The reason for that is that it allows authentication versus an authentication server, or more specifically versus a AAA authentication server. In addition, the WPA2 Enterprise Security mandates the use of AES counter mode CBC counter ciphering scheme, which makes the ciphering mechanism of the Wi-Fi equal in its strengths to cellular. And the last two features that were actually added in release 2 of Passpoint are online account provisioning, which allows the user to join and open an account online in a kind of automated way without the need to make any discussions with a human delegate, and this is done according to the standard in a kind of a universal way that multiple entities will be able to adopt it. And the last element is the ability to provide with the Passpoint information that we'll soon see how it is provided, to provide also the operator policies. Operator policies are mechanisms that intended to support operator-specific subscriber policies, policies which relate to a specific subscriber, but also recommendation on the priorities of which of the networks should be selected first, and only if it is failed or not available, what will come next. So let's have a look now at the details related to the Passpoint mechanism. So actually the first element in accessing a Wi-Fi network through the use of Passpoint is by looking at the new beacon that was formulated for the Passpoint. As we know, in Wi-Fi, the access point advertises itself by transmitting beacons or by responding to a beacon probe. The beacon, with previous Wi-Fi standardization, actually included minimal set of data which relate to the access point itself and to the network. Like, for example, what is the SSID of the network, what are the network capabilities, and this kind of information. With the Passpoint, actually the beacon was, or the information that is provided in the beacon was significantly expanded, actually to relate also to other networks or other Wi-Fi networks in the vicinity. And actually, the same access point may serve multiple business entities, service providers, and ISPs. The same physical access point may use multiple SSIDs, and each SSID may be related to a certain ISP or to a certain service provider or to a certain Wi-Fi service aggregator. So the Wi-Fi access point need to tell the mobile unit the information about all these entities that stands behind and may serve him through this single Wi-Fi physical Wi-Fi access point. So the information that is now standardized by the Passpoint to be transmitted over the beacon is as follows. First, what is the type of the access network? Is it private? Is it public? Does it belong to a specific organization? Is it a guest network? Is it a network that belongs to a cellular service provider? Another piece of information which is important is whether you can get to the internet through this network, because the previous information doesn't tell you that. It may tell you that this is, let's say, a network that belongs to some organization, but you don't know if you can access the internet through this network. So the internet bit let you know that. It also has information about the protocol, the advertisement protocol that need to be used, and we'll discuss it later, and what is the roaming consortium that stands behind, and sometimes you may be subscribed not to a specific service provider, but to a roaming consortium. And the opposite may also be true. You may be subscribed to a service provider that uses the consortium, the roaming consortium, in order to provide you the access to the network. So this is kind of initial information that was provided through the beacon, but usually it is not enough for the mobile unit to make decision. And the mobile unit may require more information in order to make the best decision to which network it should connect. So in order to get this information, now the user device actually approaches this access point after this first selection based on the information that was received from the beacon. And now it queries to a protocol which is called Access Network Query Protocol, ANQP. And it provides an ANQP request. It means, give me back this set of set of information that will allow me to decide on which of the networks that can be served through this physical access point I will choose to access. So, as a response to the ANQP, the access point provides a new set of information. It includes the name of the venue. It may be the name of the shopping mall, or it may be an hotel, it may be a hospital, or any other information that identifies the specific venue. What kind of authentication is required by the system? It may be more than one. It may allow you to use SIM, but if you don't have a SIM, it may let you know that you can also use a password and the username. Or maybe that this specific network allows you only to use SIM, or only to use password and username. So all this information is provided in the network authentication type. What kind of IP address format is used, whether it is IPv4 or IPv6? What are the cellular service providers that can be served through the access point? What is the friendly name of the operator? HotSpot, for example, AT&T Wi-Fi, and so on. So this is another batch of information that is provided to the mobile unit. And actually the standard allows to make kind of negotiation, and if more information is required, there is a protocol which is called GAS, which enables a kind of a multi-phase or multi-step discussion between the mobile unit and the access point in order to get more information if required. So to summarize the process that goes using the Passpoint, we'll use the following slide. So as mentioned earlier, in the first phase, phase number 1, the mobile unit actually scans the environment and listens to beacons transmitted by Passpoint-capable access point. When it identifies or makes a first sort and identifies access points that may be a candidate for a service, it actually requires, in most cases, more information. And this additional information is gathered or retrieved through the use of the ANQP protocol. The mobile device asks for ANQP data, and as a response, the access point provides this data to the mobile device. Based on that, the mobile device can already make a decision to which of the networks he wishes to access. And let's put attention to this important fact that all this process actually takes place before authentication and before association. So this is a relatively quick process that does not consume a lot of battery and does not consume unnecessary network resources. And to complete the process, whenever the mobile device decides that this is the network it wants to associate with, then it needs to authenticate. So only now comes the authentication. Only now, after knowing what is the best network for him, the mobile device can now start the authentication process. So as mentioned earlier, the authentication process with Passpoint is based on the WAPA 2, the enterprise version of WAPA 2. The enterprise version of WAPA 2 actually requires the authentication versus a AAA server that resides in the core network. And the authentication is made through credential or a matching credential that reside in this AAA server. So, the AAA server is mandated, is part of the WAPA 2 enterprise version, and the mechanism for authentication is done through the extendable authentication protocol, which is actually kind of a generic protocol which allows multiple types of authentication or multiple types of authentication mechanisms. Mentioned before, the Passpoint allows, or actually mandates, to allow the use of SIM-based authentication methods. So two of them are known. One is the EAP SIM and EAP ACA. Both of them does not require any involvement of the user. Actually, they're taking automatically the credentials from the SIM and do the whole process seamlessly with the AAA authentication server. But beside of that, as mentioned earlier, in some cases the mobile device will not have SIM. So, to allow authentication for mobile devices which does not have a SIM, two types of EAP flavors are standardized. One is the EAP TLS, which does not require any password, but it is based on the X509 certification. And the EAP TTLS, which is a version of the EAP TLS, which also based on the X509, but requires a manual user ID and password involvement. As mentioned earlier, in terms of ciphering mechanism, the AES CCMP counter mode CBC counter is mandated by the Passpoint. This is something that was already exist with the 802.11i. And this provides a security level which is equal to the security level used today in cellular networks.